All right, I think we're live. So, got our coffee. Let's see how this looks. Let's find the stream. Look at that. Okay, I think that looks pretty readable. I will follow. All right, great. Do this. I'm gonna have to get a better dashboard. Jesus. Okay. Last time we were going through the Creusot tutorial I was given at Popple 2026, and I actually wanted to start writing some code uh, this time. And I was thinking about defining some yes snippets for these macros. Yes, snippets for Rust macros. I actually should just do this for Rust in general and for more Rust. Yes. Rust format. Why are you so aggressive? Unclosed delimiter. Where was it? Oh, of course. Okay. All right. So in the tutorial that was given, I guess just a quick recap. So caret x is the prophecy of x. That's the final. Actually, I should write this down too. So caret x is prophecy, what they call prophecy of x. It's the final result when referenced in a proc macro, which is what these ensures and requires are the proc macros. Star x, we're really defining the meaning of these operators, caret and star. This is the initial value of x in when the function is called. Okay, and then caret x in a function body. This is where we saw last time. This is the initial value of x in the function body. So they overload this syntax, and I think that's very confusing. They also admit to it being confusing in the slides. Okay. Oh yeah, the @ symbol. I forget what the @ symbol was. We'll get back to it. So we have the @. We don't know what that is for. And then there was also a slice type. I forget what they call it. Where it's like a view of a current value, but they outlaw. Let's look. Blah, blah, blah. We'll get back to this. The @ maps Rust values to mathematical values. So star slice @ is the sequence of elements contained in star slice. So then caret slice @ is the sequence of elements in the final version of slice. So this @ symbol, this is really the denotational semantic function. This is a mapping from Rust to math, very CF set theory, because that's how denotational semantics works. Okay, it'll be right here. Snapshot, that's what it is. Okay, snapshot macro. This is to take a view. Is it actually at time t? It's take a snapshot of slice to be able to talk about its initial value in the loop invariant. I'm not sure. Snapshots are erased at runtime. That's fine. That doesn't really answer our question. So this is one of the things I don't like about tutorials that you'll see a lot. Like, and I've also written about this before. Like when you look, so like I've done Haskell for like 13 years. And if you look at a lot of like beginner tutorials for Haskell, especially monad tutorials, they'll say what it is, whatever they're talking about is, but they don't just say why or how to use it. So this says I need to use snapshot to be able to talk about its initial value in the loop invariant. Okay. But I actually want to know what it does, what it's under the hood. And the reason I want to know that is because I want to be able to have a mastery of this tool. To have a mastery of this tool means I need to be able to treat it like an operator, right? I need to be able to manipulate it to my purposes, not like a user where it's like a here's a button to press, and here's a ready-made thing. All right. It's to be decided. So I'm going to say snapshot, take some kind of view over some reference. Oh, I'm sorry. Rust formatter. Okay, where were we? Up here. Okay, so we want to formally verify swap. Swap just calls standard memory swap. The naive definition would require some constraints on T. Here we use a general swap, which uses unsafe primitives internally. This is really good. So when you write an academic paper, you want your first example, at least in programming languages, to be eye-catching, eye-popping, right? And also to be small because your size restrained. So what I like about this example is that it's something that I would have thought most tools would struggle with, which is we're using some unsafe primitives, standard mem swap, and we're treating it as polymorphic, right? It's parametrically polymorphic. Um, and the tool just works on it, and it's fine, and it's also small. Beautiful. Very well done, Creusot folk. This also is important for me because as part of this series, I've been trying to solve a skill issue I can show where I am writing a Ghoulam style Rust compiler, but I'm doing that with different arenas. So I've defined an arena type and I am using the CPU's virtual page or memory management unit to give me a bunch 12 gigs of virtual memory for my entire process. And I want to be able to use Creusot to formally verify the correctness of this arena implementation. And then I'm using, phantom types to tag my pointer type and all this stuff. So I want to be able to use Creusot to formally verify that and prove its correctness. And I think that's a more realistic use, like real world use case here, especially for someone like me who works on programming languages. All right. So we ensure we're writing the contract that we're only writing post conditions. We are ensuring that the final value of x is the initial value of y, right? The prophecy of x is the initial value of y. That means that we have successfully swapped. So then the other contract must be that the final value of y is the initial value of x, like that. Now, I wonder if we'll see this pattern more where swap takes two arguments and we ended up with two macros, two post conditions. Oh, I also wanted to say we can do it that way. We should also be able to do it this way. Whoops. And x star y. Whoop. And now I want to see if first I want to see the precedence of this of the logical and in accordance with these things. I bet you that these operators are going to bind very tightly. This should be like less tight and this should be the least tight. I want to see operator precedence because I'm going to be writing lots of these. I also want to see if there's any difference between writing them individually versus conjoining them. And you can imagine a world where that's important, where I end up writing my own macros that generate these macros, like someone like you would do in the scheme. Um, and this could end up with, like hundreds of thousands of conjunctions. Now, I wonder if their tool slows down at that or what their parser even looks like. If it were me, I would think because well, actually, I don't know what Paralite, the language looks like. But if it looks anything like SMTlib2, then you could write an early parser and it'd be super fast, as long as you were able to pull off the early parser and the procedural macro, whatever system ingests the procedural macro. Okay. I also want to see what happens with when we don't when we elide one of these post conditions. So let's do this first. And if we have a redundant one, a redundant post condition. So we do that, okay. And now it should just be cargo Creusot, which is our compile command down here. Yeah. Does it plug into eglot? Unused import. It does not plug into eglot. Or maybe it just was satisfied. Let's see. Compilation finished. Approved. 6 files. Great. I wonder where the number of files comes from. Let's do this. Hash warn. Yeah, I wonder if I can turn unused imports off for just one import. I need to look that up. Rust off screen. Unused import for one import. It's allow. Okay. Allow unused imports. Okay. I generally don't like stuff like that. Stuff like this, because I like my modules to be tight. And just from like working on GHC where, hundreds of people are going to be touching this or reading it, code has to be much more clean and neat in that sort of circumstance. So I always tend to program towards that direction, especially in working in open source. But it's fine. We don't have any deadlines here, so. Okay. Oh, yes. I already missed one. All right. So let's do this one now. Ensures what? We need to ensure that n is less than 2 to the 32 minus, it's a word, so it's not even minus 1. It's 2 to the 32. Think that'll work? Let's try it. I don't think that works. Creusot standard logic int. No implementation for Creusot standard logic int. So standard logic, that's a type error. That's saying that this less than requires n to be a standard logic int, and then my literal required a standard logic int too. At least that's what I believe. And maybe this is the constructor. closed limiter is 2. Like this. Does that work? It's defined in another crate. Says right the contract. Okay. Use Creusot standard logic. I wonder if I'm going to have this same problem for all of it. So let's see if this works. Let's get to work first. It's defined in another crate. If you import and refer to it directly, let's see what they did in the tutorial so we can at least make progress. Counter. U32 : max. That's what they did. Yes, that's also okay. It's a skill issue. So I was saying the post condition is that n is not larger, but that's actually wrong, right? Because if my at my check, if in my post condition check, if n can never be larger than the U32 max, because if it is larger, if we did overflow, that will end up causing a negative number, right? So this ensures has to be requires to be a precondition, and then we just learned how to say U32 : max. I bet you U32 : max is, oh yes, is a built-in, and then we want the initial value, right? Yeah, so this is another question I want to answer. So if caret is final value, star is initial value, what is nothing? What is just a pure reference? Yeah. Let's comment this line out. Now, does this work? Can't be dereferenced. Whoa. Okay. That seems wrong. Okay, so if n doesn't work, n star doesn't work. Okay, that works. Weird. So does the star only work in the post condition? Here they have requires counter less than 30. We should just write this. Hold on. Do they have the counter example in here? They do. It's right here. But it's a MUT32. Maybe that's the difference. Okay. Okay. Let's get rid of this. Okay. What's up? Yeah. This was my charger. All right, see ya. All right. Okay, so then we know this works. So this works. I'm gonna make a to-do real quick. So yes, snippets for Rust. And then I also want to highlight font faces for streaming. Then specifically, I want to add start. I want to add we know. I want to add questions. And then I think we have note and hack. I think that's good. Okay. Okay, so we know this works. Well, let's try this one. So in this test, we're going to use just the post condition on y, that y was swapped successfully. We're going to say nothing about x. And what I want to see here is I want to see Creusot say, hey, there's something you have missed, right? And hopefully it will. Let's pour some more coffee. I'm going to have to make some more. Okay, and hopefully it will. And does it? It doesn't. Okay. What if I don't have anything? It just ignores it. Okay. What if I have a contradiction? Like, what if the final result of y is the initial result of y? Not a contradiction, but, oh, or it could be. Yeah, I bet you this will still work. Oh, maybe not. Okay. It didn't work. Comma.vc swap t not x failed. That's the goal. How do I get more information out of that goal? I'm gonna jump to the tutorial. Where are you? I don't know much about the Y3 platform, so we'll have to start looking into that. And then we'll also need to, I want to read this publication. I also want to read the publication they continually cite about being able to do formal proofs in Rust without without separation logic, which is like the inspiration of their entire approach. Okay, this is the user guide. Basic concepts, parallel logic functions. There should be something in here about what to do when something goes wrong. Visibility. The Daphne tutorial. It's all the usual suspects. All right. I want to see, maybe I open a PR here. I want to see how can I look. So like right now, I know what's wrong, right? But that's because I've architected the example to know what's wrong, right? What is going to happen when I'm trying to, I have a big project, I'm trying to use this. How will I find out what's actually wrong here? Maybe there's a cargo Creusot help. Okay. Possible values, compile the comma. Replay the proofs, no cache. Generate a Y3 session. How to format spans. Oh, Y3 seems like it has a lot going on. Doc. New, init, clean, okay. Y3, interesting. So can I do cargo Creusot Y3? I can. Cool. All right. I'm going to stop there. Well, at least pause. So I will leave you, and then we'll pick up. I'm going to make some more coffee. So I'll leave you with zone, and then I'll turn off my mic, and we'll stay recording and streaming. All right. Turn video cap on. Okay, we are back. We'll stop zoning out. We got our coffee and a timer running for the brew. So that's right. So we wrote something that shouldn't be verified, and we saw what Creusot looks like. Oh, when it finds something that it doesn't like, or that it can't prove, and it looks bad. Like, what information? How do I know where that is? What information is given to me, the user, to now act on this? Like, I don't even see any lines, right? It just says goals bad. Okay. Um, oh, look, snapshots are in chapter 9 of the user guide, but they're like front and center. What else can we do in here? So, trusted. Maybe I open an issue on their repo to ask. Command line interface. Run Creusot. It compiles Tacoma in the verification directory and run provers. Okay, so maybe we can go find the verification directory. Up. There it is. Creusot play around bin. Haha. Okay, add one, some slice, swap. So it must create a coma file for each, a coma file in a directory for each invariant or each function that you're trying to prove over. Proof.json. Oh no. Okay, there it is. So it records the time, it used swap, or used alt ergo, which is also a solver I'm not familiar with. So I wonder if it will be faster not using alt ergo. I wonder why that alt ergo is the default. It's also the default in the flake file. So I opened an issue yesterday adding this flake more or less to their readme because, oops, because I wanted to be able to give users just a drop-in flake if they're on Nix like I am. And you immediately run into a problem where you have to allow impure, right? And you have to do that because alt ergo is marked non-free, which is fine. But I feel like their flake should allow me to choose, right? So instead of default, I could have like, um, you know, instead of default, I could have like .z3, .alt ergo. Maybe I open that pull request too. I don't know if they'd be amenable to it. I don't want to step on their toes too much. Okay, so anyway, let's imagine, let's go back here. Aha. Here we go. So here's the spans. So this is telling me, I bet you line 48 for 4. Main RS 48, yeah. It begins at 4. It begins at character 4. 1, 1, 2, 3, 4, and it ends at character 24 from 4. So I bet you the end will be 28. I don't have it, and I don't want to count. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Yeah, that's 20. Yeah, so it's 24. So it's absolute. So it says you begin at 4, you end at 24, counting from 0, the index. Okay? So that's where we get our line information. Span. So it says let span symbolic main 0, 1, 2. These are 1, 0. The indexed versions are the pre and post conditions. So I think it's actually picking up. I bet you it's picking up the commented out one. All right, so 0 goes from, is that 45 here? I'm not sure. And 43. 43 is definitely this guy. Oops, that guy. Okay. Use Creusot prelude. Okay. Let's just read some of this. Because I imagine, like I said, I wanted to be an operator. So learning the comma language is going to be important, especially if the tool is not giving me really anything, any feedback. This looks very OCaml-y. Let rec swap T0. Whoops. No, that's not it either. How did I highlight? Is it highlight MS? There we go. Yes, this looks like OCaml. So this is a function. This is meta information. This is its argument is x. Well, first argument, second argument is y. Return x comma 0 or x quote 0. This is a type maybe then? Yeah, this is a thing we'll have to look at. So you equal stop split requires stop split invariant ref mutt not BB and BB. Are these all? I wonder if these all end up being conjoined. Yeah. So, but our original error message, where's compilation? Our original error message was comma.vc swap t quote 0. Swap t quote 0. It does have the span information. So I wonder why they're not reporting it. Why does Creusot not report the pre-post conditions that fail and instead reports the, I would say, symbolic invariant that fails that it's not that fails, it can't be proved. Oh, it's time to press our coffee. Yeah, at the very least, that should be the default behavior. I kind of want to ask the devs for that. This should be default behavior. Perhaps they just haven't had time. Okay, the other thing I wanted to look at, these all have to, so we get a comma file and it proof.json, that's right. Tactic compute certified children, tactic split VC, children, blah, 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 blah. So I'm sad that they're using JSON here. I understand why, but JSON by design is like so horrendously inefficient because you can't read it. It's not like you can't read it quickly or compute on it quickly with SIMD, because you have no idea what's coming after the colon, right? It could be anything. It's really made for web stuff, not for system stuff. So the question is, where do these all get used? Like, is there imports, standard? There is a timeout. There is, it automatically found main, even though I didn't write anything for it. This is actually a good example. So from string, meta information, from string is a function, it takes some kind of typed arguments and what? What is this? I don't know. Returns us one maybe? I think this is an invariant and this is something else. Okay, we'll have to look at that. Okay. What's in here? These are, it's just gonna be data. Oh. Okay. What was Z3? What's in Z3? Just another thing? Status timeout. That's not it. Y3 find.json. Okay. All right. That's all we get. All right. Let's go back and actually do some more of these proofs. So I'm a little disappointed with that. Let's make it work again and just continue on. So this is the final x has to be the initial y. Final y has to be initial x. And that should work. It does. Okay, bring you back. Package only comma prove. And run provers on verification conditions using Y3 find. Only build package by default. Support some T. Oh, okay, so we can only run certain comma patterns. You know, often with tools like this, the real proof is going to be how do they integrate into a really massive project. Like, I bet you, like, these little exercises are fine, but I need to see this in something really large in order to really, like, trust it. Also renders contracts, ensures, and logic functions. Let's run Creusot doc. Doc. What I want to see here is I want to see docs that are generated according to the pre and post conditions that I just wrote. Where'd my docs go? Creusot's generated one warning. Okay, that was it. There it is. Finished. Generated target. Creusot doc. Do we see source? Okay. Creusot playground. Main. Oh, look at that. Aha. Okay. Let's do this. I wonder if I can. Oh. And I want to save this to my. I don't think that's gonna work, but we can try. Yeah, it didn't work. No, I don't want to compress. I actually want to. I don't want to embark. I want to become. All right. This has become a mess. Kill this. Okay, just copy. Buffer is read-only, so therefore I can't copy. Wow. Oh, my keybind's changed in HTML mode. Yes, kill anyway. C target Creusot doc source. Okay. Yep, Creusot playground. There it is. And I want to pwd. There we go. And main.rs.html. Go to file. 1, 2, 3. Think. There it is. It's just the file. Oh, that's not really what I wanted. All right. Let's do some more proofs. Let's keep it like this. I like that. Oh, yes. So we had the operator precedence. I bet you this also works. Yeah, it does. Okay, so here's what I'd want. So here's what I want. I want Creusot to report the location of things that cannot be verified. I want I want that location to hook into eglot. I want this is so I can mgn it. I want I don't know if I want anything for docs yet. I don't understand docs yet. That is the truth. All right. Okay. All right. So, mutable borrows. How do we do mutable borrows? Write the contract. So, we had swap was mutable borrows. So here we're choosing one mutable borrow instead of using both. So I think like conceptually, I want to be able to say that only one borrow happens, right? And that the other doesn't. That's like the best case scenario. That's what I would want. What are my preconditions here? I don't think I have preconditions, just like I don't in swap. So that means I'm going to be doing something like ensures something multiple times. I mean, ideally, I'm basically writing the body of this function in logic programming form. So ideally, I want to be able to say something like B and the final end result, something like B end result is going to be a bijection in uh, um, assignment is going to be a bijection in logic form. So we're saying when B is true, the result is bijective to x, to the final of x. Oh, actually, it should be initial of x, right? And then, or we're going to say not B and result is bijective to the initial of y. That's ideally what we want to be able to say. I don't. So first problem is how do we talk about the result? Second problem is how do we do this bijection? So I think we have an equals here, which is going to be the same thing. So okay, that solves that problem. So equal like that. So we really just need to know how to talk about the result. Can we make B like this? Like that? So the initial value of B, that B is not going to be changed here. It is a constant. So that should work. Yes. Okay. Blah, blah, blah. Ah, yes. What was the ampersand? Mapping Rust. Okay, so I wonder if I will need to say at B here. Will we need to say, I think we do. In fact, I bet you that there's syntactic sugar going on, that this actually is like calling something like this under the hood. Okay, so here's prophecies. Let's see how we can do it. Permutation. Yeah, but we don't need history variables for this. What we need is how to talk about result. Snapshots, blah, blah, blah. Yeah, so yesterday I talked about how this also doesn't make sense. So here, it's saying that a snapshot is a view into the value of something, right? So a snapshot of 0 is a view into like the memory location that would represent the value of 0. but 0 is a literal. It's still going to exist in some kind of memory location in like RO data or BSS in the assembly code. So this doesn't make sense because that memory location is going to be static when you compile it down. But in Rust world, it's mutable. It's a mutable X. So this is saying I can borrow that mutable piece of data, but it's not actually mutable. And so this would allow us to derive a contradiction because it's going to say, well, if I deref borrow to get 0, which is really pointing to some memory location, and I'm going to bind that to a snapshot that is derefing the final value of borrow plus 1. So you're saying that x is equal to x plus 1, which is going to be a contradiction, right? Blah, blah, blah. Yeah, borrow must end before we can use x. So the final value is this mutable borrow that is a contradiction. Um, the star caret, what was that again? I was also going to say, and this is what I was talking about yesterday, that they forbid access to final values. AI viewers stream, boo.com. Okay, we have our first bot that has entered chat. Awesome. I was also going to say, uh, this doesn't make sense because the caret is a final image of some kind of variable, right? But snapshot says, well, give me the value at some time t, or whenever time t is going to be whenever this thing runs. So what you're saying is give me the value at some time t, but the value is the final value, the prophecy of what that variable can be, which means that snapshot is actually only taking the final time t. So there should be an identity there, but they've just forbidden it, which is fine. I mean, it's going to be like, this is going to be easy to statically catch. So, loop invariance. This still doesn't allow us to talk about how we talk about results. Oh, but it does say result. Maybe it does. Okay, so let's write our first. Let's write our first post condition. So we want star b and result equal equal. And I wonder if I'll have to, so to use these variables in the body, I think I have to say, I have to declare them in the pre or post condition, pre-end, post-end result. How does it, so I don't understand where result comes from yet. Assume pre, yep. Yep. Assume invariant, yep. This is just induction. That doesn't make sense. Let's go up. Let's just try it. Result star dot x. Or, and I don't think we've also seen a not yet, right? I don't think we've seen a not in their little proof language yet. No, we haven't. Current value of y, final value. Yeah, we haven't. Okay, so let's just see what it says. Like this. And I'm missing a delimiter. I'm missing one here. Okay. Smoked query pxmzh. Are you a real person? That's the question. Ban, timeout. Well, we'll see. Aha. This is not due to one previous error. Expected a term. Okay, so tilde cannot be the not. Is it a bang? No, it's not a bang. 4 previous errors now. Equal. Can't be dereferenced. Maybe we don't need the... Expected mut t found type parameter. Interesting. So why does this work? Or not work? Again, can't be dereferenced. Function find here equal type bool cannot be dereferenced. Aha. So I think we just need to do b. That should move us forward. Oh, maybe we've got it? Nope. Equal. You're still butthurt. Expected a mut t found type parameter t. If you expected a mut t, should this be that? So I think the error there was that the result of this function has to be a mut t with some lifetime a. And because I was saying it's, I don't know, the dereference, if it's assuming star is the dereference, then that's just a t because I've chased that pointer. Let's see if this works. No. Oops. Same error. Okay. Arguments to this function are incorrect. You found this type parameter. Expected mutable reference at mut, but you found type parameter. So how do I make it a mutable reference? Let us ask. I think that's the at. I think that's what we need to do. Yes, I think that's the at. So I think that means that Paralight and Y3 don't know what a mutable reference is, right? So should this be at? What if we just did that? How far does at scope? That looks better. Method cannot be called on a at mut t due to unsatisfied trait bounds. Okay. I'm tempted to just look up the solutions now. I think I will do that. Because we tried, we've experimented. Check the solutions. Do you think this is example 0 or? Yeah. Choose. Oh, they have an if. If bx, else y. That's actually really nice. And I was right with the result. Okay. Okay. It kind of sucks that they didn't say anything like that in this tutorial. So the design of this tutorial then is like snapshots and prophecies. Like I don't need this yet, right? Like I need I need to know what is allowed in the post conditions here. Yeah, it's not very good. Okay. So I want to say if b x else y like that, and that should work. And it doesn't. Expected bool found at t. That's bad. Ah, that's why. You expected a bool, but you found an atma t, but that's actually wrong. The problem is that I need a missing result, like this. So, but because it expected a bool, I wonder if it's this error must be complaining that I didn't pass an argument. I must have somehow passed y. There's some design stuff here that I would love to dig into. Okay, now it works. Okay, so to answer our questions, this is how we would say this. We will not need to say that. I still don't know when to use at, and result is a keyword, I think, in post conditions, I believe. It's another to do more information on result. Really what's happening is this tutorial. So if you look at their tutorial, right, because I just downloaded example 0, there should be more directives. Like there should be choose one mutable borrow, and then it should be like hint you can use result equals something. Like I would say like here hint result and if are keywords. Or I mean I would just show them this, the solution, and then say, okay, now write a new one, right? Write something that uses the same thing, just some kind of if and result statement. Also, I mean, this is really focused on mutable borrows. I want to see what like just a borrow is. Like maybe it's just so trivial it doesn't matter, right? I mean, like this is an example of ownership in a loop invariant. So we'll do that next. Increment the counter and return its previous value. Let's do that one. Let's go back. Where's my... Oh yeah, let's see if we can find result and basic concepts. Maybe it's in here. Preconditions with requires. V at.ling. Ah, at is a view operator. It is needed to convert the Rust type to a logical type. Yeah, it is a semantic function. Okay. Else we could not call a ling, which is a program function and not a logical one. To learn more, see the chapter on parallel and views. All right, great. Post conditions with insurers. The return value of the function is named result by default. Yes. It's gonna pour my coffee. I think I will open a pull request to add some nuance to the examples here. This is better documentation than what I was going through. Okay. There's you know what it is? They need syntax. They need a section on syntax or like a quick guide, a quick hit of syntax. on the slice to get a seek of I32. We can then index a seek to get an okay. The result variable in an insurer's clause can be bound explicitly using closure notation. So there's some, okay, there's some subset of Rust that exists in this post condition. So result at, and then this is the logical, this is an array index in logic land. So I have symbolic variable v at index 0 is going to be equal to the result at. That's nice. This actually is pretty nice. Result binder can also be an irrefutable pattern. Okay. Great. I don't know why this is irrefutable. Oh, it's because the body is a 0 and 1. Yes. Okay. So like in a normal compiler, something like this would just get aggressively inlined and then you just have this function calls replaced with 0 and 1. All right. Let's keep going through here. Loop invariance. Even with Creusot, there are at least 3 unrelated meanings. We avoid ambiguity by always qualifying the noun invariant accordingly. Loop invariance, type invariance, resource invariance for separation logic reasoning about shared resources. We can further distinguish atomic invariance and non-atomic invariance. Okay, so they do have this concept of ghosts that I want to learn, but I think that actually is coming up. Like after loop invariance, blah, 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 a view. This is more a way to map rest values to trait view, view tie, xdef view written as x and yes, it's a projection into the denotational, the semantic domain. I don't know what this hash logic is though. Hey, that looks familiar. Result is equal to result. So requires that, and then ensures. Ooh, that's a better proof than the one I wrote. It enables arithmetic without overflow in specs. That's nice. This is how you would do an index. I require that the index in my semantic domain is less than the slice in my semantic domain, the length of the slice in my semantic domain. This is saying in my semantic domain, my index is in bounds. My post condition, I ensure that the initial value of my result is, oh, because it's a reference. Sneaky. So this returns a reference to a t or a borrow, and I dereference results, and that has to be equal to my slice, the element that's at my index of my slice. Can I come get the teapot? All right. How long have we been going? An hour and a half. Gonna take a break. Oh, be right back, and we will zone out. I think that's what we'll do. All right. Where were we? We're marveling at what ampersand actually is, and it is indeed a semantic function, which is nice. Increment the counter and return its previous value. So in this one, we want our post condition is ensures result is equal counter. I think the result is equal to n. That can't be right, right? So, okay, hold on. Counter is immutable borrow. I deref counter Oh, I keep it at n and then I increment counter. So yeah, so I'm just copying counter. Will this work? I feel like it shouldn't. I feel like it should not know that n is in there. Let's see what it says. There we go. Yes, not found in this scope. Good job, Creusot. I like that. I'm definitely going to contribute to this library, so I should see what they have open. Let's see here. Creusot examples, Creusot IDE, and a tutorial. Issues. Discussion and specs bug. They seem very new. Error message. We do not support closures that do a recursive call. That was one of the things I was going to test, so I'm happy that they already have that. Bug doc toolchain regression from stable. Yeah, I'm also curious about what their benchmarking is like. And I worry about their benchmarking because if they're not tracking it right now, then I think that it will grow unrestrained. Another big project in the works. And also, if they're not tracking it right now, I mean, frankly, like, no offense, but like, in my experience, most academics don't know how to write fast code. They write things that are logically very sound and completely correct, but it's not like anywhere near the kind of performance you would get from something like the people that write Zig or people that would do manual memory management. There's examples and there's exercises. There's tests. I don't see any kind of benchmarking. Maybe that's a thing I can add. You could just benchmark the examples or the, yeah. What I would like to see that they have, we can prove, you know, a project of certain size in time of certain amount, right? Okay, we are on result equals n. N is not bound in this context. What if I just do this? So remember there was this, they had this, oh, okay, it didn't work. They had this weird, yeah, they have this strange pre and post end result. And I don't think that's actually ever explained. Like, are there macros in here? Views as models of types, ghost code, command line interface, proof assert. What's proof assert? Oh, nice. You may want to enter, this can be useful for debug. This is how they debug. This is great. This actually might be more useful than the pre and post, than the horror logic. Because I can imagine starting with proof asserts, just like I have debug asserts and stuff in my code. The proof assert is that the logical form of x and the logical form of y is equivalent to 3 when summed. It's pretty good. Here we go. So here it is again, pre and post. What is the pre? I only have 3 simpler programs. The code before the loop must establish. All right. Well, anyway, I'm getting ahead of myself. Let's do this, and this is going to be the initial version of counter. Oh, it didn't work. VC next 32. I'm surprised about that. I see why. The result cannot be the initial version of counter because counter changes in the function of the body. So increment the counter, return its previous values. So how do I introduce n? Do I take a snapshot? I think a snapshot could work. I would like to say, actually, yeah, if I take a snapshot, does that change? So I'm thinking I want to write something like snapshot counter, like this, mod x. But see, when I snapshot, that becomes a value or a reference that's a value that's bound to a reference in Rustland. So I don't like it. The deref, can I do, what if it's just dereference counter? Okay, so I think that the guidance that the star is the initial value is wrong because it's not the initial value. If it was the initial value, this would work. It's actually just dereference. So the reason the final result of x is the dereference of y. Does that make sense? So the final result of x, let's say x points to A and y points to B. I'm saying the final result of x has to be B. The final result of x has to be B, is the deref of y. After the swap, yeah. There's something fucky going on with the star. What do you say? Where's the first time the star is used? Where is the first time the star is used? This is proof assert. Yes, we have been really focusing on mutable borrows. This is nice. The interpretation of a box of T is the interpretation of T. Yeah, that makes sense. This is because box uniquely owns its content. Yep. Yep. Final reborrows. Okay, each new mutable borrow gets a unique ID, including reborrows. However, that's too restrictive. With this, the identity function cannot have its obvious spec. Yes, I completely agree with that. Also, if you don't get the identity function right, you're in a world of hurt because the identity function is like fundamental to lambda calculus and SK combinators, which is like fundamental to everything. A reborrow is considered final if the prophecy of the original borrow depends only on the reborrow. A reborrow is considered final if the prophecy of the original borrow depends only on the reborrow. This is saying if I have a cycle, in that case, the reborrow ID can be inherited. Okay, so if the prophecy of the original borrow depends only on the reborrow, So if the reborrow is dominating in my call graph of the prophecy, something like that, if this is a reborrow of the same place, then new ID is the same. So let y is a mutable borrow of whatever x is pointing to. Else, the new ID is deterministically derived from the old. Okay. In most cases, the reborrow is final. So let mut I equals 0. We borrow I. We reborrow I through borrow. Don't use borrow afterwards. So proof assert that these are the same things. So this is like encoding the ownership system and making sure that identity works with it. Yeah. This is absolutely great. It even handles reborrowing of fields. So we have a pair, we borrow the pair, then we borrow first out of the pair, and now I show that my first is equal to the borrow field, the field first out of my borrow. This is not the case if the original borrow is used after the reborrow. So borrow I define an I borrow I reborrow I through borrow. I now reassign I in my borrow. And now reborrow won't work. Unprovable. The prophecy of borrow is 1. Yes. Which is a value completely unrelated to the reborrow. Yes. This has to be a 0. Or if there's indirection based on a runtime value, this might be really bad. So I define a vec. I borrow. I get my head out of my vec. And now I can't show. Oh. Or if there's indirection based on a runtime value. So the indirection is through my vector. And the runtime value, I mean, this is at compile time, right? Why is this needed? To prevent the following unsound code. I don't want to step through that. If borrows are only a pair of current value and a prophecy, the above code can be proven. And in particular, it proves that star star evil is equal to not star star evil, a false assertion. So I snapshot true. Okay. Jesus. I will take their word for it. I don't know. I mean, look at this. The 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 prophecy of evil is okay. Hmm. Okay, so parallelates the language used in the contracts. Okay. Okay. So parallelate is the language used in the contracts. It can be seen as a pure immutable fragment of Rust, which is access to a few additional. In practice, you have base Rust expressions, matching, function calls, let bindings, binary unary operators, tuple structs enums, projections, primitive casts, and dereferencings. That's great. That's actually quite a rich language. Logical expressions, quantifiers, logical implication, and logical equality. Okay, that explains how we had the if, Rust specification logic expect access to the final value of a mutable reference, which is the prophecy, and access to the view of an object. Let's see what they say for views. It's convenient to map a Rust type to its logical model. It's the type of So here I define a pair. I implement view for my pair. The type of my view is a tuple of tu. Logic defines a logic function that I think then I can use in Pairlight, but I will have to see. So this is a projection to my view type, and that seems straightforward. It's just returning the actual types or the actual values. I'm assuming the types get read somewhere at compile time. And now I'm saying the final result in logic land is equal to A and B, which has to be a T and a U. Yeah, that makes sense. Great. I'm not worried about termination yet. A lemma. Yes, so let's talk about logic here, and then we'll do some more proofs. Logic functions. Logic functions can be used in specifications and in a snapshot. That's nice. Yeah, so the logic is actually a macro that's injecting a Rust function into Pairlight. Logic functions manipulate variables of logic model types, such as an int and seek int, rather than normal Rust types. Yes, that's because like I32 at is int. That's basically you're saying I've moved into logic land, and now everything I'm operating on is logic land. So I bet you when you write recursive logic functions, you have to show termination. Okay, so it can handle structural induction. That's why it's structural. This is great. You need to add if you can't show structural induction, you need to add a variant expr attribute to the function. Creusot will then check that the expression expr strictly decreases. Right, so you have to show that it can do structural induction. It's like a rock or cock at each recursive call. Yes. The type of expr should implement well-founded. This is quite good. Okay, there's some real bright spots here. I'm going to run to the bathroom. I'll be back in 5 minutes. All right, we're back. Turn on the camera. Okay. Am I even streaming in science and technology? Oh, I don't think I am. Yeah. Is there a code? Programming? There's a one person streaming basic programming. Hold on, I need to see that person. Science and tech. Only 239 viewers in all of science and tech. Let's see this update in my client. Hmm. Oh, there we go. Propagated. Aha, there I am. All right, let's do the next one. So I think that this did work? Sure, save it. It didn't. Okay. Um, oh yeah, I wanted to just try -1. So before we went on this escapade, right? We said, or we discovered that perlite, and I wonder what's behind the name perlite. Let's get some more coffee. Um, is a subset of rust, a mutable subset, a mutable pure subset of rust, which is fine. So I wonder if this will just work, right? Maybe it's not going to be, okay, it doesn't. This argument influences the return type of sublogic. Does this work? No. What about this? No. What about this? Okay, still nothing. We can't subtract 1. Why? And I can't introduce n because it said it wasn't in scope. What's the answers? Let's see it. Solutions. Boop. Oh, it's actually quite involved. Result. Oh, okay. Oh, we have to play with this. Okay, so first we have a overflow check. So I need to make sure that my counter is less than U32 max. I think they have it as max. Yes. That's number 1. Number 2 is that my post condition. Number 2 is my post condition is that my result is equal to a dereference of counter, right? Deref of counter. This. Yes. Do do do. Okay. Unstable. My average bit rate is too high. Interesting. Okay. Uh, or so this is back to the dereferencing. Is it saying that my result has to be equal to my initial star counter? What I want to see is I want to see an explanation of this fucking dereference operation. Snapshots, ghost code, type invariance. Like it has to be somewhere in here, right? Trusted. Yeah, this is just accepted. Or it's probably like don't check it. Oh, there's some to-dos in here. Okay. What about visibility? I want to search. Does Markdown book... Let's just search for it. Can I search for the whole book? No. It's weird that they explain the add operator first. It's probably in the mutable borrows section. We read through this whole thing. We'll have to watch the tutorial that was given at Popple. It's probably on YouTube. Like even here, star y is the current initial value of y. So I know that this is in the solution, and that means that my result is the current or initial value of counter. Like is that an and? Or I'm sorry, an or? The current value, star y, is the initial value before calling the function. This takes a while to get used to. Yeah, it really does. Okay. Hmm. Hmm. All right, well, either way, let's learn more from this example. So we have, I'll go back to my, okay. So let's read this. So as a post condition, the final value of counter in my logical domain is equal to the current value of counter before I call my function, or the initial value before I call my function, in the logic domain plus 1. This is exactly isomorphic to what I was trying to do here, but I couldn't. And that's a little... I couldn't. This argument, does that mean... Should it just be... Oh my god. You think that works? That might work. It doesn't. Consider mutably borrowing. That's because of a type mismatch. So, okay, so maybe that's the guidance on star. Note. Initial. Initial is, I had it. I'm not gonna say initial, that's confusing. It's the value of x when, it's the value of x before the function is called. And then maybe we say the current value of x before the function is called. Okay. Still didn't work. The trait fin is not implemented. So it doesn't know that it's finite, even though we just said that in a precondition. That's fine. You want me to mutably bar. Ah, I see. Let's see if it works. I don't think that'll work. That seems wrong. Yeah. What if we do this? Oh, I was gonna be very surprised. Yeah, mutt. Yeah, okay. So it has to be the initial value of counter in the logic domain plus 1. That's what my result is, and that should work. It doesn't. Equal. Expected U32 found in int. Hmm. Ah, because result is typed. So this result is U32, but this result is going to be int. So that means that this result is a U32, has to match counter, which is a U32. Let's try that. Hey, there we go. So a slightly different, oh, it didn't work. I was going to say a slightly different solution. In general, when you're writing proof systems like this, you want to be able to give your users like the most degrees of freedom for writing their invariants. And that's because you'll start trying to prove things about a system, and you might not be able, that you might have architected the system such that like it's very hard to say +1 or -1 in the particular way that the tool expects. Uh, so what was our error? Coma Davisi next 32. U32. All it says it couldn't do. I bet you that the insurer, I bet you it's this one. No, it's not. Let's see if I remove both, that works. And if I bring this one back, that works. Okay, so it is this one. But why? Like, this doesn't give me anything to go off of. Why doesn't that work? So the way they do it, is they say ensures that my counter, right? Right, they have projections to the logical domain. So they say ensures that the prophecy of my counter, the final result, as a logic variable, is equivalent to the initial value of counter, the counter that existed before I called my function, as a logic variable plus 1. That's what they have. So they're not actually talking about the result type at all. They're just saying that after I run my function, because I'm in a post condition, this has to be true. Yeah, that seems, I think that's good. And maybe I'm over indexing on result a little bit too much. So then this one, the one that does talk about my result type, is just saying that my result has to be equivalent to like this cannot be right, right? Result is equivalent to the value of counter before I ran the function. But I'm in a post condition. So star counter must be the value of counter after I run the function, right? What does it say? Requires and ensures. That is post conditions. These form a contract. Yeah. A post condition is an assertion that is proven true at the end of the function, the return value of the function. So this star is actually the value of counter at the end of the function, which does make sense because now we've incremented counter here. Yes. Yes, yes, yes. Okay, so that works. All right. There we go. Beautiful. Okay. I think that we're going to do loop invariance tomorrow, maybe tonight, and then I think I'm going to go work on my Golem compiler. All right. See you in the next one.